In this tutorial, we're going to be looking at abstract classes. Abstract classes are a way to structure your code even further in terms of inheritance. It's where you want to have a parent class with some functionality, but the functionality that it has needs to be done in a slightly different way for each of its child classes. So in this example here, we're going to be using shapes. We're going to make a very abstract class called shape, and we're going to give this some variables and some methods, and then I'll explain a bit more in a minute. So the shapes we're going to have width and height for the shapes. They're also going to have an x and y. And they're going to have a method called draw. So we're going to have public void draw. And this method will draw the shape. Now, depending on what shape it is, we need to draw the shape in a different way. So a square would be drawn differently from a circle, for example. So this class shape here, it looks pretty standard. We've just got some variables and a method. What we're going to do is we're going to make this class abstract, which means that we don't need to declare the body of methods. It means we can leave the bodies empty and let the bodies be filled up at a later point. So to make this class abstract, we're going to come in between the public and the class. We're going to make it an abstract class. Now this abstract keyword declares this class shape as abstract. Now abstract classes work in pretty much exactly the same way. You can have methods with bodies, you can have variables. The extended functionality that an abstract class allows is that you can just end a method like this with a semicolon, which you would not be able to do normally. You can see there's an error here. That's because you also need to declare this method as abstract. So abstract. So we've made the class shape abstract and we've made the method within it abstract. You can see we can just end after writing the method name and giving it parameters if we need parameters, we can just end it with a semicolon. Now this draw method, we can create the body of this method later on in one of the child classes that we use. So we're going to make a child class now, we'll call it a circle. And then we're going to extend the shape class. And I didn't mean to delete the package. Extends shape. So you can see that this error appears here, and if we hover over it, it says circle is not abstract and it doesn't override the method draw in shape. So when you extend abstract classes, you have to override all of the abstract methods, because these are the methods that are missing bodies. They need code inside of these methods because they need to know what to do. Even if it's just an empty curly brace and the method doesn't actually do anything, we need to declare this method somewhere. So we're going to come into the circle class here and we're simply going to go public void draw, and then we can open and close the curly braces. And we're not actually going to draw a circle in this, but we're using this for the example of showing you abstract classes. So draw a circle. If I can spell circle right. There we go. So again, the usefulness of abstract classes is when you have a set of variables which is common to all of the children it's going to have. For example, if we make a circle, square, rectangle, etc. If we have variables and methods that are common to it, but we have methods which need to be done in a slightly different way each time. So we can still declare normal methods within the shape class, but because we made it abstract, we can also declare abstract methods. In this case, we've done the draw because you'll need to draw with whatever method you're using in Java, you'll need to draw each shape slightly differently. So in this circle class, you'll see we get a warning, and that's just to add the override annotation. It's not required, but it is just convention in Java to add the override annotation. It just makes the code look neater, so you know which methods you're overriding from the parents, and you know those methods from the methods that the circle class has by itself. Just to clarify, much like extending a completely normal class, we have access within this circle class here. We have access to all of the variables within the parent, so the x, y, width, and height. So now I'm going to show you a kind of shorthand notation for declaring an abstract shape class. Say you're just in your main code and you don't need like an entire new class for your for this new shape you're making. You don't need an entire new class for it. You just need to make it on the spot one time. You can simply say shape and then give it a name and set it equal to a new shape. Now that's pretty much exactly the same syntax we've seen so far. You can see we've got this error though. That's because when we declare a new instance of this shape class, we haven't actually done this method anywhere. We haven't made this method anywhere. So as a shorthand notation, after the two parentheses, after the constructor parameters, in this case we don't have any, we can make curly braces here and then declare any methods that need overriding inside those curly braces. So we've got the public void draw, and that's the only one we have in this example. So this is the kind of shorthand notation for creating a new abstract class on the spot. That's useful when you need to sort of make it one time only. You don't need its entire new class. It's not always advisable to use this method though. As you can see, it looks a bit messy, and even for the simplest of extensions to a shape, you should probably make its own separate class, but it's still good to show you the syntax that you can use in Java. You can do it this way, this shorthand way, and it is useful in some cases. And just as an added note, once you declare new shape and come inside these curly braces here, it's as if you are inside of this shape class here. So if I go into the draw method that we've declared, you can see that we have the height, width, x and y variables available from within this declaration of this class. So now, as a kind of side tutorial, I'm going to show you how we can override the object equals method in our classes. A few tutorials ago I showed you the toString method, and now I'm going to show you the equals method. So the equals method is especially useful when we're working with inheritance and parent-child classes, because it's going to compare when the one object is equal to another object. So Java has its own built-in version of that. It's got its own built-in method, and it will show if one object's equal to another, but you can override it and customize it to your definition of what equal is. So I'm going to show you the syntax for it now. Basically, say you had shape1 equals a new circle, and then you had shape2 equals another circle. It could be equal to anything, but it's useful when, say, you have a dynamic program and you're not sure what this shape1 variable is actually going to be equal to. It could be equal to a new circle, it could be equal to a new square or a new triangle, etc. So it's good to have that equals method, because the syntax would be if shape1 dot equals shape2, and this would return true or false depending on whether or not they were equal. So especially when you have custom classes like this shape class we have here, it's good to customize the definition of what equals is, because Java's built-in definition may be returning sort of wrong values for your usage of it. So if we come over into the shape class, similar to the toString method we used, we're going to add override annotation, and then we can say public boolean equals. And the parameter here is an object. We're checking if the object provided in this parameter is equals to this instance of the class we are working with. So we need to return values here. For the sake of simplicity in this tutorial, our definition of equals is going to be if the shapes x and y, width and height, are equal to the parameter that we passed in. If it's a shape, if it's equal to that one's x, y, width and height. So let's go ahead and do that now. So the first thing we notice is the parameter being passed in is an instance of object. Now, because object is the parent of every single class in Java, it's not that useful to us, because if we're comparing a shape with a non-shape, basically, it's not going to have the same variables, it's not going to have the same methods, so we're not going to be able to compare whether they're equal to each other. So we need to cast this object to shape object so we can access its variables, and we want to make sure if this obj here is not an instance of shape, we want to just return false, because if we're not comparing a shape with a shape, then they're obviously not equal to each other. So we're going to create a new shape object here called compare. This is the one we're comparing this instance of the class to, and it's going to be equal to obj, except we need to cast it as a shape. So we just simply put the class name in brackets in front of it, and that casts the object passed in to a shape. Just before that though, we're going to make sure it is a shape before we cast it, because if it's not, it will throw an error, because you can't convert one class to another class if they're not parents, if they're not children of the same parent. So we're going to use built-in Java keyword called instance of. So we're going to say if obj is instance of shape class, then we're going to go ahead and let's put the ending one down here. We're going to go ahead and continue. Otherwise, we're going to return false, because if the object passed in isn't an instance of shape, then they are obviously not equal to each other. But again, for the sake of simplicity in this tutorial, our definition of equals is going to be if this shape's xy width height is equal to the object's passed in's xy width and height. So we can simply now return if x is equal to compare.x, and if y is equal to compare.y, and if width is equal to compare.width, and if the height is equal to the compare.height. And that's returning this. The whole thing is a statement. If the x is equal to this object's x, the y is equal to the object's y, and if the width and height are equal to the object's width and height, that's going to return true. The shape is the same. So that's how you use the equals method in Java. Again, you can override this method. You don't have to override it. You can leave it as it is and use Java's built-in version, but it may not do the required functionality you need. For example, what we've just done, a class you make may need a different definition of being equal to, and that's when you override this method and you give it this custom definition, basically.